Jai Hind to all. My name is Divya Sharma and my video lecture is on Coulomb's law and electric field intensity. Now first, what do you mean by Coulomb's law? Coulomb's law states that force between 2 point charges, let it be you have 2 point charges, representing by this is Q1 charge at this point and Q2 charge at this end point. Now first, along the line joining between them means there is a line in between Q1 and Q2 and it is directly proportional, means Coulomb's law, it is directly proportional to the product of Q1 and Q2 and inversely proportional to the square of the distance between them. So its formula is F is equal to K Q1 Q2 upon R square. Now force is equal to Q1 Q2 upon K R square. K is equal to what? K is equal to 1 upon 4 pi epsilon naught. So put the value of K here and you will get force is equal to Q1 Q2 upon 4 pi epsilon naught into R square. This is the radius in between 2 point charges. Now here epsilon naught is a constant that describes the permittivity of free space and its value is 8.854 into 10 to the power minus 12 Coulomb square upon Newton meter square. So this is the value of epsilon naught and its value is also equal to 1 upon 36 pi into 10 to the power minus 9 Coulomb square upon Newton meter square. Now important values you should remember, 1 upon 4 pi epsilon naught is equal to, its value is equal to 9 into 10 to the power 9 meter per farad. Now here K is equal to what? K is equal to 1 upon 4 pi epsilon naught. If you have in a formula is in form of K, then you can put the value of K that is equal to 1 upon 4 pi epsilon naught. And here you can put the value of 9 into 10 to the power 9. Now here 1 upon 4 pi epsilon naught epsilon r is equal to 9 into 10 to the power 9. This is the value of 1 upon 4 pi epsilon naught upon epsilon r. That is equal to K upon epsilon r. So these are the important values you should remember. Now Coulomb's law is valid for point charges only. 2 charges must be at rest. So let it be you have 2 points Q1, Q2. So these should be at rest, means V is equal to 0 at this point, V is equal to 0 at this point. So 2 charges must be at rest. They apply electrostatic force on each other along the line joining between them. Now the like charges repel each other. It means if you have 2 charges, like charges means if it is positive charge, it means they will repel each other. And if they are unlike charges, it means if it is positive Q, it is negative Q. So they will attract each other. Now next point is a point charge does not exert force on itself. So these points should remember in Coulomb's law. Now you can see in the first case you have 2 charges plus Q and plus Q. So both charges are in same. So you can say here is a repulsive force. If both charges are unlike, so you can say here is an attractive force. Now problem solving approach. So Coulomb's law in 2D, if you have a question in 2D, so this is the formula, force is equal to K Q1 Q2. This is unit vector of R upon R square. This is the case in 2D. Now Q1 Q2 with magnitude, means you have to consider Q1 Q2 in magnitude, and unit vector assigned direction on the basis of attraction or repulsion, means if you have 2 charges, they are in attraction force. Attraction means if both charges are same, means repulsion force is there. So you have to take direction according to that. If you have 2 charges, unlike charges, it means there is an attraction. So you have to take direction according to that. Now K is equal to 9 into 10 to the power 9 upon epsilon r, and this is the direction of force and r is the distance between q1 and q2 charges. So this is the Coulomb's law in 2D. Let us consider a question. Here this is x-axis, this is y-axis, this is origin. Now here this is a charge plus q, this is minus q charge. It means these are unlike charges. It means there is a attraction in between these two charges. Now you can see here, if it is in attraction, so you have to consider it like this one. Now here this is a point you have to you have to find out here unit vector. If you have to find out in x-axis, so represent it like this. In y-axis you can represent it like this. So find out minus AR, because your unit vector is equal to, according to this figure, you can find out minus AX. Why it is minus AX unit vector? Because it is in opposite direction. Now here you have to consider minus. AY it is in upward direction, so take it positive. If it is in downward direction, then you have to take it in negative sign. Now unit vector of R is equal to x-axis, then y-axis. So on x-axis you can see minus AX unit vector, cos 45 degree. Here it is 90 degree. You have to find out this angle. These are 45 degrees. So write down here cos 45 degree plus unit vector of y. Yeah, now cos 45 degree. Now find out unit vector of R, that is equal to minus AX unit vector plus AY unit vector upon under root 2. So this is the value for unit vector. Now here you have to find out the force. Now Q1 and Q2 are magnitudes, so write down it Q, Q, K. Now this is R, so you can find out R according to this figure. You all know this is the distance with A, and this is your perpendicular, this is A, this is your base. If it is base, if it is perpendicular, you can find out the hypotenuse, that is equal to A under root 2 whole square. Okay, so put all these values and you can find out the force. Now Coulomb's law in 3D. Let us consider if you have 2 point charges. First one is x1, y1, z1, and second point charge, that is x2, y2, z2. If these point charges are in 3D, then how you can find out force in 3D? So if F12, it means force on point 2 due to point 1, if it is represented like this, and if F21, it means force on point 1 due to 2. Okay. Now let us consider a question in 3D. A charge of 2 microcoulomb is present at this point. Another charge minus 5 microcoulomb is present at this point. Okay. Now calculate the force experienced by minus 5 microcoulomb charge due to 2 microcoulomb charge. Now let us consider you have an initial point, this one, this is second point. Now its dimensions are given in question, that is 3 minus 2 minus 4. Here this is the point with dimension 1, minus 4 and 2. So find out the radius in between two charges, that is equal to x2 minus x1. So 1 minus 3, that is equal to minus 2 unit vector of x, because these are the dimensions of x, these are y, then z. So x2 minus x1, write down here, y2 minus y1, write down here, and z2 minus z1, write down here. So r12 is equal to minus 2 unit vector of x minus 2 unit vector of y plus 6 unit vector of z. If you want to find out the magnitude of r12, that is equal to under root minus 2 square plus minus 2 square plus 6 square, then you will get under root 44. So this is the magnitude of radius in between two charges. Now you should know the formula for Coulomb's law. Now F12, that is equal to K Q1 Q2 upon R12 ka whole square, magnitude square. This is the unit vector of R. Now put all these values. You all know the value of K, that is 9 into 10 to the power 9. Now here charge on first point, that is equal to 2 into 10 to the power minus 3. Now charge Q2 minus 4 into 10 to the power minus 6 upon R1 to magnitude square. So put the value of R12, that is under root 44 ka square. Now here put the value of unit vector of R, here minus 2 unit vector of x minus 2 unit vector of y plus 6 unit vector of z upon under root 44. So put all these values and you can find out that is its unit. This is your force, so its unit is Newton. So you can find out the result while putting these values. Now let us consider you have a charge Q1, Q2. Radius in between Q1 and Q2 is representing by R12. Now here force, here F21 and here is F12. Now this is the origin. So origin, distance between origin and Q1 charge, that is representing by R1. Distance between origin and Q2, that is represented by R2. So Coulomb vector forces between Q1 and Q2 is equal to F12 is equal to Q1 Q2 upon 4 pi epsilon naught upon R square. This is the unit vector of R, where R12 is equal to R2 minus R1. Now R is equal to R12 magnitude. Now unit vector of R is equal to R12 upon R. Now F12 is equal to, so find out while putting the values, previous values, Q1 Q2 upon 4 pi epsilon naught R cube into R12, while you are putting the value of unit vector of R. So unit vector of R is equal to R12 upon R. So you can differentiate it like this, Q1 Q2 upon 4 pi epsilon naught and unit vector of R. So you have to put here the value, that is equal to R12 upon R square, sorry, R12 upon R and here R square. So multiply these values and you will get the F12. Now F12 Q1 Q2, now here put the value of R12 as already discussed in the previous slide, that is equal to R2 minus R1. Here R is equal to R2 minus R1 ka cube. So put all these values and F21 is equal to F12 magnitude, unit vector of R in form of 21 and F that is also equal to F12 magnitude in bracket unit vector of R minus AR12. Now here F12 is equal to minus F21. So the forces on each charge have equal magnitude but opposite direction. Now this is the confirmation of Newton's third law. Let us consider an example. Here point charges with 1 microcoulomb and minus 2 millicoulomb. This is 1 millicoulomb and minus 2 millicoulomb are located at 3, 2, minus 1. This is the coordinate of first point and these are the coordinate of second point. Now calculate the electric force on a 10 nanocoulomb charge located at this point 0, 3, 1 and the electric field intensity at that point. You have to calculate the electric force here and electric field intensity at this point. This is the given point. Now here first write down the formula of F, that is equal to Q1 QK, means you have 2 point charges Q1 and K is equal to 1 and 2. So put here K is equal to 1, 2, QK 4 pi epsilon naught upon into R square. This is the unit vector of R. Now here put the value of QK, that is equal to, sorry, put the value of AR, that is equal to R minus RK. Now here put the value of magnitude. When you are finding this is the unit vector, so unit vector is equal to R minus RK upon R minus RK magnitude. So that you can multiply it with R square. So you will get here R minus RK ka magnitude 3. Now here Q upon 4 pi epsilon naught. So you can take common Q 4 pi epsilon naught outside and put the value of QK here and you have R minus RK. So this is R minus K, means you have to put here first 1 then put here 2. So write down according to that and you can find out Q is equal to what? 10 to the power minus 3 you can take common here and Q is equal to 10 into 10 to the power minus 9. So put here value 10 into 10 to the power minus 9. Now here you can find out 0 minus 3. So you will get here minus 3. 3 minus 2 you will get here 1. 1 minus minus 1, you will get here 2. So here also 0 minus 1, you will get here 1. 3 minus 1, you will get here 4. 1 minus 4, you will get here minus 3. Now here how you will get? Now under root, you can put 0 minus 3 ka whole square, you will get here 9. Now 3 minus 2 ka whole square, you will get here 1. 1 minus 1 ka square, you will get here 4. So 3 by 2 means you are taking here under root. So under root is removed by when you are taking by 2. Now here similarly you can find out 0 minus 1 is equal to 1 means under root you can take, that is square. 3 minus 1 ka square, that is 16. 1 minus 4 ka square, that is equal to 9. Now by 3 by 2. Now put here the values. Now here you can put value epsilon naught. So put here 36 pi. Now you can put all these values and find out the result, and that is equal to what? That is minus f is equal to minus 6.507 unit vector of x, because these are the coordinates of x, then y, then z. These are x, y, z. So you will get the force in form of coordinate x, y, z milli-Newton. So this is your force. Now you have to find out the electric field intensity, and you all know the formula of electric field intensity, that is equal to what? E is equal to F upon Q. So Q, you all know, it is given in the question that 10 nano Coulomb. So put here 10 into 10 ki power minus 9. This is the force, as you can see here, milli-Newton. So put milli is equal to 10 ki power minus 3. So put all these values and you can find out electric field intensity is equal to minus 650.7 unit vector of x minus 381.7 ay plus 750.6 az kilovolt per meter. So this is electric field intensity. Now principle of superposition. In a system with multiple n-point charge particles, the net force on one particle due to other charges, maybe charges 2 or more, is the vector sum of each force due to each individual charge, and each individual contribution is unaffected by the presence of other charge. Now F is equal to what? F is equal to Q into Q1 R minus R1 upon 4 pi epsilon naught R minus R1 ka magnitude Q, plus now for the second charge, Q Q2 R minus R2 upon 4 pi epsilon naught R minus R2 ka whole cube, magnitude cube. Now let it be, if you have more charges, then you can find out for n charges, Q Qn R minus Rn, means let it be you have n particles. So you can find out for n, that is R minus R1 upon 4 pi epsilon naught upon into R minus Rn magnitude Q. Now you can write down its formula, means you can find out if you have more particles are there. So K is equal to 1 to n Q upon 4 pi epsilon naught. Now summation K is equal to 1 to n Qk. Now R minus Rk upon R minus Rk ka magnitude Q. So this is the general formula for when you have more than one particle, 2 or more particles you have. Okay. Now here you have to find out the electric field intensity. Force per unit charge, means electric field E is equal to limits Q tends to 0 F upon Q. Now here E is equal to, E is your electric field intensity, that is equal to F upon Q, and unit of E is Newton per Coulomb or volt per meter. Now electric field intensity due to point charge. Let it be you have a charge Q and you are considering here point that is represented by P, and charge on this point P, that is equal to Q naught, and radius in between this Q and this Q, means this point, that is equal to R. Now if you want to find out here force at this point P, that is equal to K Q naught, means this is the charge on this point and this is the charge Q naught at this point P. So Q naught unit vector of R upon R square. And here if you want to find out the electric field intensity at this point P, so that is F upon Q naught. So you can put the value of Fp means force at point P. So put this value and divide it by Q naught, that is equal to KQ unit vector of R upon R square. And unit of electric field intensity at point P is equal to Newton per Coulomb or volt per meter. Now formula of electric field intensity in 2D. So electric field intensity at point P in 2D is equal to KQ upon R square unit vector of R. Now here you should remember Q with magnitude and unit vector. You have to remember it according to, if you have two charges and they are attractive, means like charges or unlike charges. So direction is depend on your charges are attractive or repulsive. Now here in 3D, let it be you have a point charge. This is 1, this is 2, this is point P. It's called, this is your charge on starting point. Now here these are the coordinates x1, y1, z1, and these are the coordinates at point P, x2, y2, z2. So how you can find out electric field intensity at point P? That is E12 is equal to KQ unit vector of R12 upon R12 का magnitude square. So here Q with sign, you have to write down here Q with sign. Now electric field intensity at point R due to a point charge located at R dash is readily obtained. Now here E is equal to Q upon 4 pi epsilon naught unit vector of R upon R square. Or you can put, if you have Q dash charge, now Q up in bracket R minus R dash upon 4 pi epsilon naught R minus R dash ka Q, because you are putting here value AR, that is equal to what? R minus R dash upon R minus R dash ka magnitude. So put the value of unit vector of R here and you will get the result. Now electric field intensity for 2-point charges, let it be you have 2-point charges Q1 and Q2, and here this is the point P. Now in distance between Q1 and P, that is representing by R minus R1 point, and distance between this point P and Q2, that is R minus R2. Now here you have to write down electric field intensity between two charges. ER is equal to Q1 upon 4 pi epsilon naught in bracket, means in magnitude R minus R1 ka square, this is your unit vector at point charge 1, plus Q2 upon 4 pi epsilon naught magnitude R minus R2 ka square A2. So this is the electric field intensity for 2-point charges. Now electric field intensity at point R due to n-point charges located at R1, R2, R3 or up to Rn. Now how you can find out for these points? Electric field intensity is equal to, you have to use the general formula for as we have done for the 2-point charges. Now Q1 R minus R1 upon 4 pi epsilon naught, magnitude में R minus R1 का magnitude Q. Now here this is for second point and this is for N. Now this is the general formula. E electric field intensity is equal to 1 upon 4 pi epsilon naught. Now value ranges from 1 to N. Now QK R minus RK upon magnitude R minus RK ka magnitude Q. So this is the general formula when you have n-point charges. Now this is the question, what is the value of electric field intensity at a point, you have a point 034, if the charge of 5 microcoulomb is present at origin. Now here you can consider this is the figure, this is your origin point, this is x-axis, this is y-axis, this is z-axis. Now here you can consider this point 034. Okay, now write down here 34. Why you are writing here 34? Because this is y-axis, this is z-axis. So write down here 34, and this is your 3 magnitude on a y-axis and 4 magnitude on z-axis. Okay, now this is the point, you have to consider this is the point 3, 4, and charge on this point is Q naught. Now radius, if you are finding radius from origin to this point, that is equal to 5. Why it is 5? Because this is 3, this is 4, you can apply here Pythagoras theorem and you will get the radius. Now here you have this point, you have to find out electric field intensity at this point. So first you should know, you have to find out AY, this is AZ, and this is your direction of electric field intensity. Now you can put all these values and find out your Q is charge. Q charge is given here 5 microcoulomb, and you can find out the value of tan theta 4 by 3 from this figure, cos theta 3 by 4 and sin theta 4 by 5. And you can put all these values in the formula, that is equal to electric field intensity at point P is equal to K Q upon R square unit vector of R. Now here put the value here K. Now this is also given in the question. Q value you can put, Q is equal to 5 into 10 to the power minus 6. K is equal to, already you know, 9 into 10 to the power 9. Now R already you have find out, Q R is equal to 5. So put here 5 square, that is equal to 25. Now here put the value of unit vector of R, that is A Y unit vector cos theta plus A Z unit vector sin theta. So put here the value of cos theta and sin theta and you will get the result. And units of electric field intensity is equal to Newton per Coulomb or volt per meter. So find out by using these values and you will get the result. Now thank you.